Good morning. Our project for this semester was a smart home project. Our advisor is Dr. Monemi, and my team will consist of me, Gary Huang,
Ram Patel,
Simon Sayed,
Eduardo Castellanos,
Akash Verma,
and Salvador.
So what our presentation will consist of will be what is a smart home and how does it work, the technology that we have used from hardware to software, the motion detected light switch project, the automated garage door opening system, air quality monitoring using the Raspberry Pi, a voice recognition based home automation system, a thermostat control system, and the water monitoring system. So what is a smart home? A smart home gives you ultimate control over your home by automating the lighting system, dimming blinds, electrical appliances, and anything that can be integrated into your house. Smart homes are used to provide improved convenience, comfort, energy efficiency, and security. So how does it work? Anything in your home that uses electricity can be put onto the network and at your command by either voice command, remote, or the computer. Smart home works with fairly simple systems, which are receivers and transmitters. When the receivers detect a certain signal from the transmitter that issues a command, for our project, it will be a command to the Raspberry Pi. And the technology that we used was mainly the Raspberry Pi 3B, multiple sensors for each individual project. The server-side programs that we used were the LAMP web server, the HTML coding, and Python and CSS coding. The main connection devices we used were just routers and port forwarding, as well as switches. So for my project that I created was the motion detected light switch. The motion detected light switch that I created was going to be consisted of a PRR sensor, a Raspberry Pi, as well as a smart plug. The app that came with the smart plug, whichever one that we bought, was going to be integrated in with the Raspberry Pi. And how it worked was that whenever there was a motion detected by the PRR sensor, it would send a signal over to the Raspberry Pi to either switch the plug on or off. Here's a basic schematic of the PRR sensor connected to the Raspberry Pi. And this is a video of how the sensor actually worked. And then here's the cost breakdown. So as you can see, the most expensive part was actually the Raspberry Pi, but everything else was relatively simple to acquire.
The second part of our project is a smart garage door opener, which gives you the ability to open and close your garage door with real-time notifications. It can be controlled from anywhere as long as you have an internet connection. With this, there is no need to carry around a special remote just for your garage, since most people have a smartphone readily available. For example, this can be used in a case where, let's say, someone forgot their key to the house. You can just let them in through the app on your garage door opener on your phone. Also, if you forget to close your door, this will automatically close the door within a given time frame. Next slide. So here's a schematic that shows how the garage door opener connects to the Raspberry Pi, a two-channel relay, and the magnetic switch. Here's a little video demo of how it works. And here's a parts breakdown list that shows the costs of each of all the components. As you can see, the Raspberry Pi was the most expensive thing, but besides that, everything else was pretty easy to come by.
This is the air quality monitoring using Raspberry Pi. This device measures the CO2 value, TVOC value, temperature, and humidity to run the math. You can see the air quality live on the dashboard and see a clear indication if the air quality is getting bad and dangerous, and hence take required action. All the data from the monitoring system is shown on the dashboard of a common server. This is the live setup of our air quality sensor. This is the schematic we follow to set up our air quality sensor, and you can see the wires used and the parts used. This is what we can see on a dashboard. This represents all the data which comes from the air quality sensor. The way we measure the data is the PM values cannot exceed 10, and anything more than 10 is considered dangerous. And all the data is plotted here. Coming to the components, this is the component list for the air quality sensor, and this also represents the total price we spent on the system.
Okay, next part of our project is voice recognition based home automation system. This project aims to provide a voice control interface to the users to control the appliances. Speech recognition is provided using an online speech to text platform called WIT. And the home automation system listens for the user speech, and whenever it defines a phrase is identified, it triggers the corresponding action to turn on and turn off the appliances. The voice recognition based home automation system for paralyzed and elderly people are mainly focused on controlling the electrical appliances in the home, like switching the light on or off, turning AC or on or off, etc. With the voice as interacting medium to control devices, it becomes more user friendly and easy to operate the home appliances. And here's the schematic for the voice recognition home-based automation system. On the left, you can see that Raspberry Pi is connected to the 4-channel relay module, and from 4-channel relay module, you can connect all your appliances. Next slide, please. And here's the interface for the system, where on the left, it shows the voice command given by the user speech. And on the right two images, it shows the web interface where you can just turn on or turn off your appliances. Next. Here's a little demo about how it works. Next slide, please. And here's the component list and the total cost of the project. Next slide, please.
This is the thermostat control system and door lock. It's basically replacing a common thermostat control that people have, like an analog one, with a LED touchscreen. It controls all functions such as the fan, heating, and cooling that are common in most thermostats. And it's using a DHT22 temperature and humidity sensor to collect the data of the ambient temperature to either turn on the cooling, turn on the heating, depending on what it is. It's integrated with the door lock, which is using an RFID scanner and RFID tags and a 6-pin digit display to access the door. And it's using a Raspberry Pi to read and relay information between the database using PHMIM. And on the right, you see a common thermostat wiring label that I used to connect it with my thermostat and is common in most cases in the United States. Then we have the DHT22 humidity and temperature sensor right there. Next slide. This is the basic schematic of the thermostat and door lock combined together. Most of the wiring was basically used by the LED. In this case, it shows a 16-channel relay, but in my case, I only use 4 channels since I needed to control the cooling, the fan, and the heating. And finally, the door lock, which was a 12-volt door lock in my case, so it will use a 12-volt power supply to either turn off or on depending on the signal from the Raspberry Pi. And then the DHT temperature sensor that's communicating with the Raspberry Pi to get the information for the ambient temperature. Then we have the common interface. On the left top, we have the home screen, which just asks you to present the token along with a thermostat button to enter that interface. You have on the right, you have the pin setup for the 6-digit pin that you need to enter, and then an access granted screen that's provided if you provide both the RFID tag and the pin, and it's successful. And you have a thermostat screen right here, which just shows heating, fanning, and cooling, Celsius and Fahrenheit if you want to routine those, an off button to turn off any of the functions, and then a scroll wheel which goes from 0 to 100, and depending if you heat or cool, will heat and cool the house. And an exit button which just takes you back to the main interface. Next slide. Then you have the PHP-MyAdmin database. On the left, we have the add is used to add or remove people based on their name. You add or remove the RFID tag, and then their 6-digit pin to access the door. On the right, we have all the failed and successful attempts for accessing the door lock and the thermostat. And it's there for the user to see who's trying to get inside of the house or try to fiddle with the thermostat, usually for the nosy dads or controlling dads. Here we have 2 videos. One is just showing the door lock working and the other one showing the thermostat working. Next slide, please. And then we have the total cost of the entire setup. Most of the cost came from the LED touchscreen and the power supply, along with the door start, but that's door start can be gotten on cheaper depending on where you get it. And then the LED was just current with COVID, it was a little bit more expensive along with the power supply. So you can get it for cheaper.
Finally, we have the water monitoring system. The water monitoring system uses utility sensors that are necessary for any home, especially a smart home. They provide a range of information going from water usage, water quality levels, as well as detection of water pressure. In case there is a leak in a pipe, you'd be able to detect the loss in water pressure and then be able to adjust for that. From left to right, we have a Hall sensor, which measures water flow in liters per minute. And then we have a turbidity sensor, which will measure the clarity of water and check for water quality. And then we have the water pressure sensor, as well as a thermometer to check temperature of the water in Celsius. Next slide. Here we have the schematic for the water monitoring system. Next slide. On the left is the picture of all the sensors hooked up and wired to the Raspberry Pi. And then we have an example of the PHP MyAdmin databases for the sensors, as well as an example code of inputting a desired report interval or sample time for each of the sensors when they take the information and display it again. Next. And here are the costs for all the parts required for this project. Next. And here is the interface for the web server that we used. The first one, the door lock, will direct you to another PHP MyAdmin database, which will display thermostat information as well as the access log for the door. Then we have the motion light tab, which will just show you if motion was detected as well as if the lights are on or off. Then we have the water sensor tab, which will direct you again to the PHP MyAdmin database and show you information on the sensors. Then we have the voice activated smart home tab, and that will direct you to a web GUI, which will allow you to turn on or off lights that it is connected to. Then we have the garage door tab, which will allow you access to the app, which allows you to open or close the garage door. And finally, we have the air quality tab, which will direct you to the dashboard for the air quality sensor information. Next. Due to COVID, we were unable to meet in person, so the entirety of this project was done virtually. In addition, we had to purchase individual Raspberry Pis, which led to an increase in the total cost. Although this project was a proof of concept for a smart home, this project could be improved further by increasing sensors and connecting more appliances, as well as implementing everything into a dedicated app. Next. Finally, these are just the references that we used. And here will also be links to the demo videos. Thank you for listening to our presentation on Smart Home.